Hi, my name is Harrison Skelton, and I'm participating in Challenge 2016. Today, I will be explaining problem number 36 from section 2.4, and then I will be explaining problem number 24, I believe, from 2.6, number 28, problem number 28 from 2.6. And then I will find the derivative of f of x equals the square root of x at x equals 1 by taking an appropriate limit. Okay, so starting with number 36 from 2.1, the problem asks us to take the limit as x approaches 0 of sine 5x over 4x. So what we're going to do is we know that the limit as x approaches 0 of sine x over x equals 1. So this looks awfully similar to this. So we're going to try to manipulate this to make it look like this. So how we do that is we're going to multiply the top and bottom by 5 over 4. And what you end up getting is 5 over 4 sine of 5x over 5x. And it looks like this. So then sine 5x over 5x, we can take these 5's away right here, and now we have sine x over x. So now we have 5 over 4 times 1. I just made that x sine x over x and made that equal 1. So now the answer, the limit as x approaches 0 of sine 5x over 4x is equal to 5 over 4. This is your answer for that problem. Moving on to the next problem. It asks us to take, let's see, number 28. Yes. It asks us to find the limit as x approaches infinity of 2 plus the square root of x over the square root of 2 minus the square root of x. And it looks like this. So what we can do is we can, since it's approaching infinity, we can multiply the top and the bottom by the square root of x, the largest term of x. So that would give us, well, actually, no, we would divide the top and the bottom. I apologize. Divide the top and the bottom by the square root of x. So then we can look at the limits of each term individually. So that would give us 2 over the square root of x plus the square root of x over the square root of x all over 2 over the square root of x minus the square root of x over the square root of x. So now this is what we end up with. And now we can take the limit of all these terms individually and add them together and divide them at the end. Okay, so the limit of 2 over the square root of x is 0. Square root of x over square root of x gives us 1. 2 over the square root of x gives us 0 again, and the negative square root of x over x gives us negative 1. So basically, we will end up having 0 plus 1 over 0 minus 1, which simplifies down to 1 over negative 1, which simplifies down to 1. So the limit as x approaches infinity of 2 plus the square root of x over 2 minus the square root of x equals 1. Okay, moving on to the last problem. It wants to know it wants us to find the derivative of f of x equals the square root of x at x equals 1 by taking an appropriate limit. So what we can do is we can say the limit as x approaches 1 of the square root of x. Right? So they give us this. And one way we can do this is we can use the expression f of x minus h minus f of x all over h. So if you plug f of x into here, we will get, and if we say that x equals h, then we can substitute and get the square root of x minus 1 minus the square root of x all over 1. So then basically what we do is we plug in x equals 1, and we would get the square roots of, I'm sorry, I made a mistake. Here is supposed to be x plus h, so x plus 1. So that would actually give us the square root of 2, since 1 plus 1 is 2. Then we subtract that square root of x, which is 1. And that's all over 1. So then we say the square root of 2 minus 1, the square root of 1 is 1, all over 1, as such, like this. And that can be simplified down even more to say the square root of 2 minus 1. And this is the answer. So the derivative of f of x is square root of 2 minus 1. Those are the problems that we have today. Thank you for watching, and I will see you soon.